All right, we are about to pull back the curtain on JavaScript's secret weapon. You know, the thing that lets it juggle a million tasks at once without even breaking a sweat. Welcome to our explainer on the one and only JavaScript event loop. I mean, have you ever just stopped and wondered how your browser does it all? You've got animations flying across the screen, you're clicking on things, data's being fetched from some server. How on earth does it all work so smoothly without the whole page just freezing up? It really does feel like magic, but I promise you, it's just a very, very clever system. Oh, and if you're a developer, you have definitely faced that question in an interview. You know the one. The one about set timeout with a zero delay versus a promise. It's a classic for a reason, right? It's the question that really separates the people who get it from those who are just, well, guessing. Well, let's stop guessing. Seriously, in just the next few minutes, you are going to master the one concept that unlocks everything we just talked about. Let's dive in. Okay, so first things first. Before we can get to the solution, we have to understand the core puzzle of JavaScript itself. There's this fundamental constraint that makes this whole system necessary to begin with. And here it is. JavaScript is single-threaded. That's it. It has one and only one thread of execution. That means it can literally only do one single thing at any given moment. So, how does it handle thousands of simultaneous tasks? That is the puzzle we're here to solve. And the solution to that puzzle? It's this beautiful, elegant mechanism. It's really the engine that makes all of asynchronous JavaScript possible. So let's meet the event loop. So what does it do? Well, the event loop has one primary job. It's like a relentless gatekeeper for the main thread. All day, every day, it just asks one simple question over and over. Hey, is the call stack empty? If the answer is yes, bam, it grabs the next waiting task from the queue and puts it on the stack to run. It sounds simple, but it is incredibly powerful. And it's basically managing two main areas. First, you've got the call stack. Think of this as the what's running right now zone. Then you have the callback queue, which is basically the waiting line. It's for all the tasks that are ready to go just as soon as the stack is clear. The event loop, it's the bridge that connects these two worlds. Okay, theory is great and all, but let's actually see this thing in action. This is the classic absolute textbook example. We've got a console.log for start, then a set timeout with a 0 millisecond delay, and then another console.log for end. So take a second. What do you think the output order is going to be? All right, first step, no big surprise here. We get start. That console.log is synchronous. It gets pushed right onto the call stack. It runs immediately, and it's done. Simple enough. But then, here's where it gets interesting. The very next thing we see is end. What happened to our timeout? Well, even with a 0 millisecond delay, set timeout is an asynchronous function. The browser goes, okay, I'll handle this, and hands it off to a web API. The callback gets put in the queue, and the main thread just keeps on chugging along to the next line without ever stopping. And then, finally, once the call stack is totally empty after start and end have both run, the event loop finally does its thing. It looks over, sees the stack is clear, grabs that set timeout callback from the queue, and pops it onto the stack to run. And just like that, you see inside set timeout. This perfectly shows you the core idea in action. All right, if you understood that, you're already ahead of the game. But now we're going to level up. This is the part that interviewers love to dig into just to see if you really, really know your stuff. Turns out there isn't just one queue. There are actually two, and one of them gets a VIP pass. So get this, we have macrotasks and we have microtasks. You can think of macrotasks, things like set timeout or set interval, as the regular general admission line. Microtasks, on the other hand, these are mainly your promise callbacks. They're in the priority lane, the express queue. And the event loop has one unbreakable rule. It must process and clear out the entire microtask queue before it's allowed to even look at the next macrotask. Okay, so now for the ultimate test. We're pitting a macrotask, set timeout, directly against a microtask, a resolved promise. Both of them are ready to go pretty much immediately. We already know starts and end are going to print first. But the real question is, of the two async tasks, which one wins the race to the call stack? And the winner is the microtask, every single time. As soon as this synchronous code is done, the event loop's first stop is that priority queue. It sees the promise callback waiting there and runs it immediately. It doesn't even glance at the macrotask queue yet. This is that classic interview gotcha moment. And it's only after that microtask queue is totally empty that the event loop finally goes back to its normal routine and says, okay, what's next in the regular queue? And picks up our setTimeout callback. Understanding this priority system is absolutely the key. So, how do you take all this and actually use it to knock your next technical interview out of the park? Let's break it down into a super simple, actionable plan. Here you go. This is your interview cheat sheet. When they ask you about the event loop, you just hit these key points. You mention the call stock, that's for what's running now. You mention the callback queue or macrotask queue, and you definitely mention the priority microtask queue for promises. Now, if you want to get bonus points, you can also talk about how web APIs, like for timers or network requests, are what handle the work in the background before a callback even gets to a queue. And here's how you show you have an even deeper level of understanding. You explain what happens when things go wrong. You tell them what not to do. For example, if you write an infinite while true loop, you are blocking the call stack forever. That means the event loop never, ever gets a chance to run. Your entire app freezes solid. No more clicks, no timers, nothing works. And look, if you want to just boil this all down into one perfect, concise sentence that will make any interviewer nod their head, this is it. This is your magic line. It shows you get the core problem that JavaScript is single-threaded, and the elegant solution, the non-blocking model that the event loop makes possible. Okay, let's wrap this all up. We've seen exactly how a language that can only do one thing at a time manages to create these incredibly responsive, non-blocking experiences we use every day. It all comes down to this one powerful central idea. So if you're going to remember just one thing from all of this, make it this. The event loop is basically the traffic controller of JavaScript. It's constantly directing things, preventing traffic jams, giving priority to the express lane, and ultimately, it's what keeps your entire application running smoothly. So now you have it. That's the fundamental knowledge that underpins pretty much all of modern web development. You finally understand the how behind asynchronous JavaScript. So really, the only question left is, with this new power, this new understanding, what amazing responsive applications are you going to go out and build?